Number 1. On the unit circle, sketch a terminal ray that forms an angle of 240 degrees. Determine the sine of 240 and the cosine of 240. So, we need a unit circle. That's our first thing we're going to do, is make a unit circle. That's not a straight line. That is. And I need a circle. You definitely need to sketch this picture every time that you do these types of questions. And I need an angle that forms 240 degrees. So I need to spin over 240. Well, definitely not in the first two quadrants. 270 is the third quadrant, so it stops somewhere in quadrant 3. In quadrant 3, my sine and my cosine, cosine is x, sine is y. They're both negative. Both of my values there are negative. The true thing we need to figure out, though, is what is our reference angle? What is our reference angle, this blue angle I just colored in? Well, that whole rotation, this whole rotation there is 240 degrees. This point is 180, so how much is left over? Our reference angle is 60 degrees. So we have the sine, we need to know the sine of 60 and the cosine of 60, because that's our reference angle, but they're both going to be negative, because cosine is negative in the third quadrant and sine is negative in the third quadrant. If you look at your special right triangles, the sine of 60 is negative radical 3 over 2. The cosine of 60 is negative, the cosine of 60 is a half, so negative 1/2. Which means this point on the unit circle, that point on the unit circle there has the coordinates cosine, sine. Negative 1/2, negative radical 3 over 2. That point there says the cosine is negative 1/2 and the sine is negative radical 3 over 2. Big idea is finding your reference angle and knowing that both sine and cosine are negative in quadrant 3. Number 2, suppose that 0 is less than theta, which is less than 90. So theta is in what quadrant? Theta is in quadrant 1. And the sine of theta is 1 over radical 3. Well, I'm in the first quadrant, so let's sketch that. Let's sketch that I'm in the first quadrant. The sine of my angle, well, let's say that's theta, is 1 over radical 3. Opposite over hypotenuse. My opposite is 1. My hypotenuse is radical 3. So I'm not in the unit circle here, but these ideas still apply. What's the value of cosine theta? Well, how do I find the third side of a right triangle? The Pythagorean theorem. Leg squared plus leg squared is hypotenuse squared. X squared plus 1 equals 3, so x squared equals 2. So x equals the square root of 2. So what's the value of cosine theta? The value of cosine of theta is adjacent over hypotenuse, radical 2 over radical 3. We can leave our answer like that for now. How does our answer change if we let theta be between 90 and 180 degrees? So how does this change my answer if I go into quadrant 2? Well, in quadrant 2, a point in quadrant 2 is negative x, positive y. So remember, cosine is our x values. This value would be negative because in quadrant 2, x is negative, which means that cosine is negative. We can't use the unit circle here because our hypotenuse is not 1. We're not on the unit circle, but we can still use right triangle trig from last year. 3. The vertices of the triangle ABC have these coordinates. Let theta be the angle between the x-axis and ray AB. Well, let's sketch a picture. We have A is 0, 0. My pen, go green. A is 0, 0. B is 12, 5. Over 12, up 5. That's B. And C is 12, 0. So yes, this is a right triangle. Let theta be the angle between the x-axis and ray AB, so theta is in standard position there. And I want to know what's the sine of theta and the cosine of theta. Well, if this is the point 12, 5, I am clearly not on the unit circle. This has a height of 5, and AC is 12. Well, I have two sides of a right triangle. I should probably find the third side. That third side is, well, 5 squared plus 12 squared is c squared. 25 plus 144 is c squared. 169 is c squared. 13 is c. So what's the sine of theta and the cosine of theta? Well, we can't use the unit circle. We have to use plain old right triangle trig. The sine of theta is opposite over hypotenuse, 5/13. The cosine of theta is 12/13. Now, if I actually was to go into the unit circle and make a circle with a radius of 1, if I had, let's say that circle has a radius of 1, this point right here would have the coordinates, that blue point has the coordinates cosine sine, 12/13, 5/13. That's the point on the unit circle, because on the unit circle it's cosine theta is x, sine theta is y. But when we're not in the unit circle, we have to use right triangle trig. If the cosine of theta was negative 4/5, what are two possible values for the sine of theta? Well, I know that cosine is negative. And where is cosine negative? Where is the cosine function negative? Well, if you think about it, cosine is our x values. Cosine is negative in quadrants 2 and in quadrants 3, because they're both negative in quadrant 3. So I could have a quadrant 2 angle. I could have a quadrant 2 angle here. Or I could also, let's do it for a quadrant 2 angle first. Cosine is adjacent over hypotenuse. Adjacent is 4 over the hypotenuse of 5. So this is a 3, 4, 5 right triangle. So the sine of theta, well, it's definitely going to be positive, because sine is positive in the second quadrant, is 3/5 in the second quadrant. If I go into the third quadrant, it's the same thing. Same reference angle. My adjacent is 4, my hypotenuse is 5, my y value is 3, and when I'm in the third quadrant, sine is negative. So in the third quadrant, it's negative 3/5. That's when I'm in quadrant 2, that's when I'm in quadrant 3. So it's knowing that idea of when is sine positive and when is cosine positive. You need to know that cosine is your x value, sine is your y value. So in quadrant 1, they're both positive, and in quadrant 4, cosine's positive, sine is negative. Number 5, use the unit circle to explain why the sine of 135 equals the sine of 45. But the cosine of 135 is not the cosine of 45. So, make my axes, make my circle, make a nice unit circle here. Label that 0.01 so people know it's the unit circle. And 135 is in quadrant 2. We'll call that angle 135 there. Remember, you make your perpendicular back down to the x-axis always. But I don't really care about 135. I more care about my reference angle. That green angle right there is my reference angle. 135 plus what gets me to 180? Well, my reference angle is 45 degrees. In the second quadrant, in quadrant 2, and the word explain means I need to write some kind of sentence. In quadrant 2, we know that sine is positive. We know the sine function is positive, but the cosine function is negative. The reference angle for 135, is 45 degrees. So because the reference angle is 45 and sine is positive, We know the sine of 135 equals the sine of 45. But the cosine of 135 equals the cosine of 45, but because I'm in the second quadrant, it's negative. So it equals negative cosine of 45, not plain old cosine of 45. And that has to do with us being in the second quadrant. Finally, number 6, if the sine of 50 is a and the cosine of 50 is b, find the value of the following expressions. The sine of 130. Well, draw a picture, make my unit circle. 130 is definitely in quadrant 2. I truly care about my reference angle, though. I don't care about 130. My reference angle is in purple here. What plus 130 gets me to 180? My reference angle is 50 degrees. In quadrant 2, we know that cosine is negative and sine is positive because sine is your y value. So it's the sine of 50. The sine of 130 is the same as the sine of 50 because that's my reference angle and it's still positive. So the sine of 50 is a, so the sine of 130 is a. It's the same value. They have the same value because they have the same reference angle and sine is positive in quadrant 2. Cosine of 230. Cosine of 230. Gonna make my unit circle and sketch a picture. 230 is past 180, so it's in quadrant 3. I need to figure out what's my reference angle, though, after I drop my perpendicular back down to the x-axis. My reference angle, well, that's 180. The whole thing is 230. So if that's 180, how much more do I have to spin? I have to spin another 50 degrees. But in quadrant 3, both cosine is your x, sine is your y, both cosine and sine are negative. So this is equal to the negative cosine of 50. Well, what's the cosine of 50? B. So this is equal to negative b. Sine of 310. Make a unit circle because we need to figure out what's the reference angle. My reference angle is, well, there's 310. It's definitely in the fourth quadrant. I need to make my perpendicular. My reference angle is here in blue. There's my reference angle. This spun me around. That green angle is 310. That blue gets me back to 360, so my reference angle is 50 degrees. Well, quadrant 4 are plus minus. Sine is your y. Sine is your y value, so it's negative. So this is negative sine 50. The sine of 50 is a, so this is minus a. The value of that is minus sine 50. And finally, this last one is a challenge question, the cosine of 40. Well, the cosine of 40, there's my unit circle. There's 40, but I don't know anything about 40. I know things about 50 degrees. And this is where we take a step back to Common Core geometry and say, wait a second, the cosine of 40 is equal to the sine of the complement. What's the complement of 40? 50. The sine of 50 is a. This was me just having fun here, making sure you remember your cofunction relationship. But again, it is not a big idea at all in Algebra 2. Just want to make sure you remember it because it's an important idea going forward, especially when we get to graphing.